All right, guys, welcome to class. All right, so have you had time to look at the video? Did you do any practice on what we did last time? Can you hear me?
Yes.
Okay. I'm sharing my notes. Can you see my notes?
Yes.
Okay. All right, so are we ready? Do you have any question? Anything you need us to quickly clarify before we proceed to today's talk? I already shared this note with you with the projects therein, and I've shared all of my repositories. I will have explained how you should clone them, practice with them so that you're able to claim the experience. All right, so you have done all of the basics relating to Kubernetes. So what we want to do today is go to a very major project. Very, very major. In fact, it's so major that we call it production grade. It's not just for classroom, it's actually what is achievable, deliverable in the. All right, so production grade EKS. EKS means Kubernetes. Kubernetes that is created and managed for you by AWS. We'll call it, what does E mean? Elastic. Elastic Kubernetes services. Elastic Kubernetes. Kubernetes is too big and too complex to be managed by just one person trying to set it up. So what we do at the industry, at the production level, is to outsource the entire building management of the entire Kubernetes cluster to a reliable third party. And who could be more reliable than the cloud service provider stuff? All right. In the case where you are outsourcing to Azure instead of AWS, then we'll call it AKS, Azure Kubernetes, or GEK or GKS, which is Google Kubernetes Platform, GKP, I think. Anyway, so let's go ahead and deploy this. So where's the project? So this is the project. Have you already done this? Did you complete this project with
I don't think so.
Can you take it? Let's be sure. Now we don't waste your time teaching what you already. I don't think so.
We didn't do this.
Okay.
We didn't.
All right. So this is a typical interview question. So you are setting up infrastructure. Apart from the infrastructure we set up the last time, we already said infrastructure can be a Docker server, Ansible servers. Now we also mentioned Kubernetes. Now we're going to look at Kubernetes cluster. We don't call it Kubernetes server, we call it Kubernetes. All right. We are going to cite this as an example. So you need all of the practical experiences to be able to say, yes, I have done that. To be able to do that, we have already set up our IDE. We are familiar with all of the resources and protocols and services that we should have running before we can do. So let's just go ahead and start the project. So to start the project, we are going to create the project folder. Let's call it revision. And then I'm saving it inside DevOps2. All right. So let's go to our VS Code and open that folder and begin to work. Remember that I already saved my, in fact, I'm going to delete. I can start all. The only thing I have inside the folder is my key pair. All right. So I'm going to run. Please feel very free. This is meant to be revision so that you can understand. Feel free to stop me anytime to say, sorry, what did you mean behind that? All right, so this was another class. So I'm going to close this folder. And then I'm going to open a new folder, open folder. And this folder, like we said, would be DevOps2, and this is the particular, where is it? One that I created for this project. All right, so I open. Now we can start. To start this project, as usual, the codes, all of the codes, infrastructure code, the codes for deploying the application, all of the codes have already been written by the different units, the different subject matter experts, the entire team working together, and all codes have now been saved in the code repository in GitHub. So we do have that already in place. So the first thing we want to do to deploy this project is clone that code repository that pertains to this project. Everything relating to this project we have met, we have debated, we have gone back and forth, error, trial, and all of that. Now we have the codes ready finally. So we want to clone that code into, as a DevOps engineer, or as each member of the team, we have to have a clone of that code. All right, so to clone that, we're just going to do, you remember your git command. So we're just going to come here. I'm going to start a new terminal. New terminal will be not PowerShell, but WSL terminal. What do I have here? Do I have a AWS installed here? Yes, this is the right terminal because I have multiple terminals. So I just recognize it because others probably do not have it. All right, so I'm going to say git clone the repository where I have all of them. My username, the item. My password, I don't have that. Let me quickly go to my notes and go look for Control F, GitHub account. Let me just do the token. I said it. Token. Okay, so right here, Control C, and then Control V. All right, so we have a clone of that. So if we do ls now, we are going to see that ls -l, we are going to see that in addition to the key pair that I said, which was the only thing I had, now I have the code base. All right, so let's go into cd eks ls -l. Shows me that this code has three parts, three directories. So one directory is for the team that work with me on infrastructure as code. So they have written all of the codes that I need to deploy my infrastructure. So the codes are right there. Another team works to develop the application, the developer, and their codes are supposedly written and saved in here, the application that we are trying to deploy. And then there is this other part where I take this code, build the code into artifact, convert the artifact into image, and then deploy the image into this infrastructure as application. So that part is called deployment. So I have this other part that is called deployment. So we're going to, as a DevOps engineer, I'm going to put all of this together and come up with the final project. All right, so the first thing I want to do has to do with setting up my infrastructure provisioning using Terraform. I'm going to go into this folder, cd infrastructure, and ls-l confirms that I have not just one file like we normally would have for simple classroom work, but so many files. In fact, I can go from here and I can look for, what's infrastructure? Infrastructure here, right there. So I open the infrastructure folder and I see all my Terraform files. backend.tf, ers.tf. So it's not just a simple case of main.tf. We have so many TF files. We have variable.tf, we have version.tf, we have vpc.tf, provider.tf, output.tf. So basically, let's just run through this. So, and the note will help you do that. So what we want to do is
So I tried to open the link for that GitHub repo, but it's saying full for. Is it a private?
Yeah, but I shared with you, so you should be able to open the particular. Did you submit your email address?
I did.
Do you have a GitHub account?
I do.
So why would they do that? You are a collaborator, so you should be able to. Okay, let's look at that together after. After this project, during class. You share the error you have. Well, what scenario we have all of those codes also in the Google repository that I shared with you. Did you get that?
Yes.
The Google repository also has all of the code. So what scenario we're not able to clone from there, they just log on to the Google. But we'll see together. We'll look at it. There's something called TerraGrant that I wanted to introduce. Before I do that, I want to make sure we didn't jump that. Looks like we jumped it. So let me go up. Let me go up to introduce you to something, a new package called TerraGrant. TerraGrant, yeah. So I'm introducing TerraGrant here. Where's the installation? Okay, install TerraGrant. Okay, this is the installation. All right, so we're still following the note. We're on track. So TerraGrant is a layer, a wrapper around Terraform. When it comes to complex projects like this, Terraform alone might not be. It's better to just wrap TerraGrant around the Terraform so that you can achieve this easier. Right? So that's why we're introducing TerraGrant, a theme wrapper for Terraform that makes managing Terraform configurations easier and consistent. And like you have seen, this is not just a simple case of main.tf, it's kind of complex. We are going to install TerraGrant to help us do this job. All right, so to do that, we are going to run this command. All right, so just to demonstrate how that works, I'll take this command, Ctrl+C, and then I'll come here to install TerraGrant. So I'll run that command. It will download TerraGrant. And then after that,
you install it on that infrastructure.
No, anywhere. As long as working from the prompt, anywhere you don't have to be in any particular directory. Yes, I just happen to be in the infrastructure directory right now, but even if I wasn't there, it's just a command. It will work from anywhere. But if the file that I want to work with is inside here, then I have to be inside here to run that command. All right. So the next thing now is to say sudo move the TerraGrant from where it is now into, of course, you've done Linux, so you understand that command. Ctrl+C, and then we'll say right click for Ctrl+C, then we'll right click for Ctrl+V. Right? And to do this, I need my privileged password. So my username is manager, my password is akin2024. That's my sudo password. You didn't get it? What's the problem? akin2024. All right, so that's correct. And then what's the next thing I do to complete the installation? I say sudo chmod. You already know the meaning of that. All right. So give access, and that is done. So TerraGrunt is done. To confirm if TerraGrunt is installed like every other program, it's always the name of the program or application, then minus version. So Control C, Control V. All right, so that confirms to us that TerraGrunt is now installed. All right. So having installed TerraGrunt, we now want to go into infrastructure directory like we did. And this time, the infrastructure we're talking about is Kubernetes. All right. Of course, we have been doing this, so we assume that you already have this ready. Otherwise, you'll not be able to do your. All right. Just to confirm that we have that ready, I'm going to say AWS configure, Control C. So AWS configure, I'm sure you're already used to AWS configure alone, but this time we're adding profile for the user dev. So instead of just doing AWS configure to add your credentials, we are now doing AWS configure minus profile dev, because the user that will be doing all of this job is the user dev. All right, and that confirms that we already have it set up because we are seeing credentials here. So that is already set up. We already have a secret access key assigned. The default space where all of this will be deployed is US East 1, and then the default format of our output is JSON. All right, so all of that is set up. But what if it wasn't set up? Then it will ask you to enter your user ID, your user secret, and all that. And you know how to do that. You just create a user account, an IAM account for dev in your AWS account, extract the credentials, save them somewhere, and then you can copy and paste as they are asked. Now we have a profile with which we would connect through AWS CLI to our AWS account and begin to deploy the processes. All right, beautiful. We can test that our profile is working by entering any of these commands. As long as we do not get error message, it replies with something. It means that, oh, the connection is established and is able to use this profile to connect with our AWS. I did get a reply telling me that the person that is doing this connection is user dev, and he's connecting right now to the account ID that we're using that user ID. Oh, that's fine. So everything is fine. As preliminaries, setting up this project, presumably for the first. All right, so now that everything is fine, let's start the project. And to start the project, we first of all cloned the entire repository. And that was why it asked us for that, and we provided that. So the next thing we want to do now is go to infrastructure directory, and then we are going to directory project, and we are going into this file. In this file, let's go into that file, aregbesola.acl. Please remember that you are not necessarily the only one that would create the whole of this file. This is a big project. This is an entire factory. You liken this to real life situation being set up. So it's not for one man to know all of this. And then what would the entire IT team be doing? So like we said before, this is a team effort. Everybody works together to come up with one person may have done this, another person may have done this, and then they work together to ensure that the two are working fine and so on. All right, so now we'll go into terraground.acl. So we'll go there, and I will create more space to see the code. This is the code for terraground.acl. What does this file do? This file, this manifest, is going to create a bucket, a storage in AWS Cloud. And let us call that storage AWS, let's call it our or class app 1, 2, 3. All right. Once it creates that storage, what else is it going to do? That storage will be called backend. So it is to this backend that the configuration of the Terraform will be stored. Because whatever we are doing on our own system is not available to the organization. It's not available to the company. So it is when we upload to the company's repository storage that is now available there. What we are saying here is create a storage in AWS company's account, and then of course encrypt everything that goes into that storage. That storage is called S3 bucket. And then our backend.terraform, you are going to lift it from my local system here and go and save it into this storage. And then you are going to, this code is going to create provider.tf. If one already exists, it's going to overwrite it. And that provider.tf is the file that it will use to complete the work. So our TerraGrunt will configure TerraGrunt to automatically store our TF state files in our S3 bucket. And that S3 bucket will first of all be created.
So, sorry, can I ask you a question?
Yes, feel free every time.
I remember Mr. Raymond saying that sometimes when you paste copy and paste code on VS Code is not aligned. I think there's a way to make it align. I don't know, especially when you want to install some maybe application on the server. You know, when you copy a code, maybe you copy from the PDF, you paste it, it will not align. Even when you copy it to Notepad, and is there a way you can make it to align or?
No, don't copy from PDF. Copy from Notepad or copy from Word. Yes. Or better still, once you copy from Notepad, from Word, from wherever, go to ChatGPT and give it to ChatGPT. It will help you align it.
Okay, when I copy from the PDF, paste it to ChatGPT to align it.
Yes.
Okay.
Then you cannot take it directly from ChatGPT. Okay. So these are the different ways. So ChatGPT is like the best option, right? So we're going to take an example. Okay. And then you see how that works. So that is much easier than trying to do it by yourself. All right. So back here now. Yes. So that's what this one does. If we go back to the note, we are going to delete any existing S3 bucket so that it will create a new one for us. If we already have Terraform directory, which is the directory that Terraform creates every time it's initializing, we're going to delete it so that all of this job will be fresh work. That's just the whole idea. New job, fresh job, nothing taken from. So let us delete these three files. So is there Terraform under infrastructure? Is there .terraform? No, I cannot find any. It doesn't exist. Okay, that's fine. What about provider.tf? Does it exist? Yeah, look at it. It exists. We have asked the terragrunt.acl to create a new provider.tf. So we're going to delete this. Delete. So that is gone. And then according to the note, we also asked it to create a new backend.tf because it's going to create a new backend anyway. You cannot use an old one. We'll click this and we'll see. All right. So we have made this requirement. We change the name of the profile so that in case the name already exists, we will not have a case of, it's a universal name. We cannot have two names. We haven't done that now. We can now say init, Terraform init. Control C. And very important that we see what we do. I don't remember if I say, so I'm going to see. So I'm going to do Terraform init. And while that one is taking a while to initialize Terraform, the ecr.tf is the manifest that will create our Elastic Container Registry. You remember what that is? It's just like a Docker Hub. But whereas Docker Hub is public where you push your image to, this one is specifically private to your organization. All right. If I say, give me other examples of container registry other than Docker Hub, it could be ECR, ACR, Microsoft Container Registry, and so on and so forth. So now, with this one example now, you now see how to create. Not just how to create a container registry, using code, but also the work of container registry. What's the work of container registry? The image that we are going to create from all of this project, that is where we are going to push it to, for it to be available centrally for the organization. If it's on our system, the organization that we work for doesn't have access to it. So after we have created the image, this is where it goes to, so that we want to deploy it to our, what do we deploy our image to? Once we are ready. Sorry?
Docker Hub.
We save the image in container registry. Container registry example is Docker Hub. But we're not ready to use it. We just saved it there temporarily so that when we're ready to use it in future, we can take it from there. So now we are ready. Where do we deploy it to from Docker Hub, or from, in this case, from our ACR? You guys are not ready for interview yet, right? So you pulled an image from Docker Hub. Where are you deploying the image to?
Docker registry.
Docker registry, Docker Hub is the same thing. So you pulled an image from container registry. Where are you deploying it to?
To the node, the working server.
The Kubernetes.
Oh, all right. Record. So we have this. We have this. This is development. This is operation. In between, you are doing all of this work called CI/CD. Therefore, you are dev. And then along the line from code to artifact to image, you are saving the image in a place called container registry. And then you got the image and you deploy it to container registry. And like we said before, that the tool that is responsible for anything that has to do with container, image, that tool is Docker. And this place to which the Docker would save your image is called container registry. Example of container registry, Docker Hub. So my question is, we are pulling container registry from here to continue this work of converting our code from one end to our application at the other end, called end-to-end deployment. I'm saying when we take code from here, what do we do? I mean, what do we have in here? What do I have inside here? What do I have inside here?
Image.
Yes, image. So I'm saying that if once we take image from here, what do we do with it? That's my question. When we take image from here, because we have worked all the way through several weeks to eventually get the image and we saved it here. Let's continue the work now. Because until the work gets to this end, we have not completed the work. So when we take image from here, what do we do with it? That's my question.
We pull it.
When we pull image from here, what do we do with it?
We deploy it to a container.
We deploy it. Deploy it to where?
To deploy it to Ansible or to a container.
This is where we deploy it to now. Why is this so hard? I'm sorry to be strict, very strict on you. You need to wake up. This is so, why are you mentioning container, blah, blah? We deploy it to
Operations,
operation.
sorry, operations.
So that was my question. We deploy it to operations. Okay, now let us zoom into operations now. Let me focus on these operations now, where your answers will be useful. So can you give me an insight as to what is inside this operation? If I now focus on operations, where we learned cloud solutions architecture. So what and what can you identify? What is inside the operation? When you say you deploy to operations, give me an example of something inside operation.
We have a cluster which is made up of several nodes.
What mentions simple thing? Don't go and mention big thing that you cannot defend.
Wow.
So what and what do you have inside operations now? One.
We have servers.
We have servers. What else do you have inside operation, especially as it relates to your deployment here?
We have pods.
You are talking about Kubernetes as if you are strong in Kubernetes. If I ask you questions in Kubernetes now, you will not know it. I am sure. So mention the simple things that you know within operations that are here. Servers, simple. What are servers called in AWS? They are called EC2. All right, so we have EC2s. Now, within, what are the different, please bear with me, I'm sorry. I'm just trying to be a little hard so that you can wake up. I don't mean to be hard.
It's okay.
Bear with me, please. It's just class. I'm just a teacher and a trainer. It's just, yeah. All right, so within our operations, we can have 3 different environments. Maybe I've not mentioned that. In fact, we can have multiple environments. We can have our development environment. We can have our testing environment. Of course, we can have our what's the third one that is common?
Yeah.
Yes, we can have our QA environment, test QA, and then when we deploy our application to this environment, that is where the whole world can now see the environment. While it's here, it's only for developers to work on. While it's here, it's for QA and the testers to work on. And then ultimately, it is ready and it is now deployed into this place where, oh, the application is live, it has been commissioned, everybody can see it now. The chairman, Elon Musk, has been there and it has launched the application. What is this environment called? Production. Yes. So they are all within our operations. Now, what's the question that brought me here originally? The question that brought me here originally was for you to answer that when we deploy images from our container registry, we are deploying the image to operation. That's what I wanted.
Okay.
We are deploying to operations. So what we are doing today is we are building an end-to-end CI/CD that would, 1, create our infrastructure, 2, build our app from the codes, and 3, deploy the app from here all the way here. So this is the one we called infrastructure. This is the one we called deployment. And this is the one we called, what do we call it in that directory? We call it basic, DevOps basic. All right. So let's go back to our project. All right, so we have successfully done Terraform init. So the next command to do now is terragrunt init. Look at it. We are going to do terragrunt init. Remember, the primary thing that we would achieve with terragrunt init is that it will initialize the creation on an S3 bucket, and then every time we now have our terraform.tf state, it will be migrated, it will be pushed. It's actually migration. Migration is the word. So we do our terragrunt init, and it tells us this bucket does not exist. Do you want me to create it? We say yes. Why for you? And it will create it should create that bucket. Beautiful. That's going to take a while. Provided there is no error, then we'll be able to proceed from here. Okay, so while this one is taking some time to set up,
So Terraform has to be initialized before we initialize TerraGrunt. Is that what you said?
Correct. That's right. That's right. All right, so TerraGrunt is now initialized. Now, guys, let us start the work. We are going to do our TerraGrunt validate, TerraGrunt plan, TerraGrunt. So exactly like Terraform, the same thing. So TerraGrunt validate, it's just that we are now operating Terraform from TerraGrunt. So let's clear so that you can see the result. TerraGrunt validate. This is the climax of DevOps. All right, so all right, so let's not just wait for that to happen. Let's look at there's this other one. Look at another TFR, EKS cluster. It means that an EKS cluster will be created and the details, the code that will do that EKS cluster creation is right here. All right. Okay. Let's give this code to ChatGPT and see what it will see. The code is perfect, it's already running. But let's see if ChatGPT will say, will agree with us that it's so Control V. We'll not even see anything, we'll just press enter. That code. So ChatGPT hung. So let's repeat that. Be hung. Oh no, it responds. I'm not sure. So let's do it using Control V. The Terraform configuration you've provided sets up an AWS EKS, Elastic Kubernetes Service cluster along with 2 worker groups. That training has become really easy. So even something that you do not understand, you can just copy, give it to Jan, and it will explain to you in detail what is part of. So it did not say that the training has error. Normally to tell you the code can be improved and it will give you a number. So that is what it does. So our code is good. So our TerraGrunt validate was good. Let's move to the next command. TerraGrunt plan. You see, you know, these are not really required, but I'm just using it to show you how these things work. It's not really required that we do TerraGrunt validate and TerraGrunt plan. You can just go ahead and do TerraGrunt apply. But because it's the first time you are seeing this code and you are not sure whether it will work or not, we're just doing this. Anyway, so back to this. So even though you did not write all of these codes by yourself, it is required, it is compulsory that you understand what the codes are doing. So that in future, if for example, we now decide that T3 medium is too small for our operation server, we now want to change it to a bigger server of T7, for example, or M2, then you know exactly where to go to make that modification. Yes, exactly. If you do not understand it, you don't know where to go. It will just be a matter of coming here. Or maybe you deployed this for Bank of America. Now you are deploying the same project for Wells Fargo. You know where to go to change the name from Bank of America to Wells Fargo. and so on and so forth. As for the codes, they will last forever. The same codes, repeatable. Just use it over and over and over, unless, of course, because of changing technologies, basically changing technology and other things, you want to improve on the code. In which case, it's still the same code. You just take the code and then give it to the AI that will improve on it for you. Then you just copy and find the new code and paste. Basically the same. All right, so there was no error from there. So finally, we are now going to say teragrunt apply. So what does that mean? It means that all of these codes, all of these different files, all of these manifests that we have defined, teragrunt should pick all of them and execute them all together so that we now have a so that we can now set up our full infrastructure. In this case, the infrastructure we are setting up is not just a server, it's not just an EC2, it's not just a Docker server, it's not just 3 or 4 Ansible servers. The infrastructure we are setting up here is what? Anybody? This project, what kind of infrastructure are we setting up right now? Is teragrunt helping us to set up?
S3, I think. That's good. No.
So the infrastructure we are setting up here, as we said at the very beginning, is EKS. EKS means Kubernetes.
Okay.
EKS means AWS managed Kubernetes cluster. So because we are setting up Kubernetes cluster, we do not need, in our operations, we are no longer using this model. So what I drew here earlier on, for the case of Kubernetes cluster, all of this is wrong. I'm going to remove all of this. Because Kubernetes is much bigger than all of this. So I'm just removing all of this. And now I'm going to set up my cloud. And all I will have inside the cloud will be my Kubernetes cluster. It's inside this Kubernetes cluster now that I'll have. Although when we talk about Kubernetes cluster, we don't really talk so much about the content. But just for illustration, I'm just going to draw them with thin line. That actually will have servers working inside the cluster, or rather work with the Kubernetes cluster. So you see that one model of deploying to operations is to simply set up a server and do Docker. Another model is to set up multiple servers and do Ansible. Yet, the biggest and the most current of the models is to set up Kubernetes cluster. So that's what we're doing. Our operations is now Kubernetes cluster. Kubernetes cluster. And that is what this teragrunt is doing for us. And because there are so many parts to the Kubernetes cluster deployment, it's going to take a while and take up to 20 minutes for you to set up all of it. Because like we said, it's like setting up a factory. Put all of the engine in place, put this there, put the raw material tank, put the belt that will convey the raw materials to the tank where it is the distilling or whatever is done. Yeah. All right, so before I attempt to go into each of these manifests to show you what they look like on the inside, I need you to ask questions. Do you understand what we are trying to do? Any questions?
So far, it's clear.
Okay. Yeah, Richard.
Yes, yeah, it's clear.
All right. Okay. So while this one is going on, let's go into main.tf. What does main.tf do? Can you recognize anything here?
Which one are you talking about? The main.tf manifest?
Yes, the manifest. Yeah, even if you don't, no problem. But you can always. So,
looks like the hosts.
It's
where all the IP addresses.
The host.
You use the data source to get.
This is the manifest. I don't see data source.
Okay.
Somebody mentioned host. So that host does what? So you define your host, define your token. Define the token, and then it attaches the certificate. Anywhere you see this base 54, it means encryption. So you are as an interview question. You are encrypting the content so that they are not just appearing plain. All right. Nothing much there, but at least you can tell one or two. So output. This is where you define all of the outputs that this whole project should give to you. You are saying at the end of all of this job, give me the cluster ID of the cluster that you created, give me the cluster endpoint IP address, give me this, give me that, everything you need the project to show to you, to give to you, so that you can now use them for what you want. The ECR, the URL to the ECR that it created for you. You need it so that you can refer to it. We define all of the things that you need as output. We define them inside here. Right. Variables. This one will contain strings that you do not want to make permanent. For example, earlier on we talked about that the name of this project for now may be Wells Fargo. In future, you may want to change it to Bank of America, for example. So in that case, you don't want to hard code the name of the project. You want to leave it as variable. It just means that you can always change it in future. So anything that you do not want to make permanent, you want to be able to change in future. Put them here under variable so that the whole program managed and run by Terragram can always come here to pick the name of the cluster and then use it. Come here, pick the name of the ECR and then use it, and so on and so forth. Versions. There are so many applications that will be involved in the creation of this infrastructure. So many other tools like AWS. What version of AWS would you be using? Okay, like Kubernetes. You are going to use Kubernetes. You are saying when you are downloading and using Kubernetes for me, don't use anything lower than Kubernetes version 2.0.7. Right? This is where you present the versions of all of the applications and tools that you need for this project.
Sorry, what about if the client or company wants a specific version? So you have to use that.
Exactly. This is where you put it to say it has to be this specific version. So instead of greater than or equal to, then it will have to be equal. It has to be that version. Or here you are saying the version that I am using must not be less. The organization I'm working for does not want anything less than 3.10, because versions that are less than that are no longer supported, and the vulnerability and the risk of using them is high. So I want only recent version. Yes. So whatever it is that the organization, the Bank of America, you are building this for, whatever it is that they want, which you would have already agreed at the meeting. In fact, it may not even be you putting this. The person that went to the meeting and saw everything, tested the current application, and decided, not one person, the team that decided that, oh, this is the version we want to use. They already gave you this to help them put, or they put it by themselves. So to answer your question, yes. All of those details, they will be entered.
Can you show us the security groups .tf?
Okay, let's see. Security groups.tf. All right. So for AWS security group, we are saying open only port 22 to and fro. So unlike before where we just say open all ports, this case is different. We are opening only port 22. All right, so only port 22 should be allowed to come in here, ingress. And then because there are two workers group that made up the Kubernetes cluster. So for the first group, ingress should be 22. For the second group, ingress should be 22. Then resource for security group, VPC ID, pick it from somewhere else, from the module called VPC. Whatever you have in the module called VPC, pick the ID from there, then bring it here. And then when you bring it here, allow open port 22, that's what it means. Open port 22. And then assign and use these IP addresses for that VPC.
I want to ask a question, man.
Yeah.
If assuming we're asked to open like 3 ports, do we have to do it one, like if for ingress we do it for 3 ports, like for ingress we do
Let's do it. So what 3 ports do you want to open?
Let's say 22, 80, and 443.
22 open command or Terraform scripts.
I want to do 3 at the same time, and I don't want to be.
Port. Yeah, we're doing it now. Port 22. Port 22, 80, 443. So this is the answer. All right, so this is the normal answer, but your question is,
yeah, I was thinking,
can this be factorized
as a list? Like,
not necessarily list, but let's see how it will do it for. Or maybe you are right. So you said list, right? So it's actually defining list. Okay, that's good. But again, it's not really. Okay, so let's try one more time. And we have all the ports listed together instead of separate. All right, so apparently this is the best way to do it. So this is shorter than the normal one, right?
okay. Yeah, I was looking for something shorter because that's security code can take up space.
Yeah. So yes, this is one way. I'm sure if you, maybe, I'm not really sure. Maybe if you prove further, might make it even simpler. But for me, this is good enough. So this is the list. 1, 2, 3, and then for egress, for all going out, everything is okay. So in future, once I'm not there to ask that question, just ask ChatGPT to give you an idea. It doesn't mean that if you just copy and paste it will work right away, but at least it gives you an idea. By the time you tweak 1, 2, 3 times, you might get it. So your port 22, your port 80, your port, they are open. So even if you have, so with this understanding now, it means that if you want to open more ports, you just copy this line, paste it, and then you can just expand it from a list of 3 to a list of 14. All right, that's the question, right?
Yes.
So let's see. It's our deployment the question you asked about, the question the lady asked about security groups. Did you find what you were watching out for?
Yes, I just wanted to see how it was defined in there.
Oh, okay.
What ports were open, but I can see it.
Yeah, okay. So depending on the...
So that's where we also define the CIDR blocks that were the company. I see it down there.
Yes, CIDR block. Yes, apparently so. Yes, that's a good one. I would have expected that should be presented under the VPC. Let's say VPC. VPC. Oh, yeah, but private VPC. So how come we still have those ones? Right? So they were data private subnets. So the subnets are defined here, public subnet defined here, and then the CIDR defined here. So what are those ones then? If this is the real CIDR, 10.0, then what did we see there? Let's go back to the security group. 10.0.0/8, 172, and 192/12. Let's do it again. Let's go back to VPC 10.0. It's not 16, so it's different. What do we have? It's not 16 for the VPC. All right. So this is for the entire network. What about for security group? Oh, security group is specific to the machine. Oh, there are two different things. Bear with me. So there are two different things. So this is specific to the machines that we are using within the Kubernetes, but the other one is related to the entire network. So what it means, if you understand networking to that extent, is that each machine must take at least the first parts of its IP address from the network, and then depending on what which of the subnets you have the machine, then you can further configure. So for this one, it is correct because the entire subnet is /16. /16 means for the entire subnet we are using 8+8. We are using these two, but this /8. /8 means this part must be constant for all of the machines. /16 means that the first two parts must be. Let's go back to VPC. All right. So to come back to your question, the CIDR was actually defined here for the VPC. So those ones that you saw there, they are derivative of what has already been defined for the VPC at the level of the nation. Yeah, maybe a bit confusing, but you are not really required to understand that deep unless you are now a specialist in it. All right. So your VPC, and of course, it's not always ChatGPT. We know where we got this from. For example, if you go to this place now, this exact template that we modified to get this. If we go here to this source, if we copy source, Ctrl+C, and then we go to Google, and then we'll pull that here, and then we'll go to that place. We are going to see the template that gives the source that gives us that. All right. So, and it's the same for all of the other modules. So to create a VPC, we just take it from here, like you said yesterday. So usually the defaults are okay because they are specific to the VPC. In other words, they are not universal. It's not like because you use them on this VPC, you cannot use them on another VPC. So, however, if you know networking enough, you are the subject matter expert in networking, and you feel that I know enough to be able to modify, to change it, then you may change it. So this is what we are using. All right. So now that all of this have been completed for us, look at it. We will now have all of this output. Look at the output, exactly what we said. Once you complete your job, give us all of this. So let's copy all of this. as the output because we'll be needing that from time to time. This is the end of the text. So you can see, and then we'll go to Notepad, and then we'll see Control V. All right, we have our app. All right, guys, so the deployment of our infrastructure is complete. By the way, let's quickly go to cloud. At least it's the first time. So let's see whether that Kubernetes cluster was actually deployed in cloud. Sign into the console as the root user. All right, so let's find out. First of all, EKS. Was EKS created? EKS, Elastic Kubernetes Service. If we click that, we see that an EKS was actually created called test cluster in akin. So yes, it was created for us. What about ECR? We said create an ECR. Was it created? Elastic Container Registry. So if we click that, we see that that was created. It's called Go App Repo, exactly as we asked it to do. What about S3 Bucket? Was it created? And there are many more resources that we have created. How many can we check? The ones that are visible on it. Yeah, it was created. One we created today. Okay, I had one before that I didn't do it. Look at the one we just created today. And if we open it, see current directory, we see that terraform.stage file has been saved into it and migrated to the TFC. It's the most important file. If you lose this file, you lose all of the Terraform configuration. It's so important that you cannot afford to have it not backward. So what about the EC2s inside the Kubernetes cluster? All right. With these few points of mine, you should be convinced now that everything that we did there and we asked to create, they were actually created and they are right here. We didn't have to come here to see them, but just look at it. 3 million servers that join together to form the Kubernetes. What about the CloudFormation code that wrote the CloudFormation stack? So instead of CloudFormation, yeah, where's the stack set? I started to see something. CloudFormation. Yeah, there should be stack. CloudFormation. Let's refresh. What's going on? I expect to see something. Restart with existing resource info. Registry. Yeah, did we already check ECR? I think we did. ECR, it's a content. But CloudFormation, am I missing something? CloudFormation should you have something for it. Okay, so let's see. Go back to the note. Yes, okay. Okay, so this is not the case where we have a CloudFormation. Okay, so I'm mixing things up. Well, let's confirm from ChatGPT. Let me just confirm. Because if I'm not seeing it there, then I'm missing something. Let's ask. Does AWS need or use cloud formation to create EKS? AWS uses cloud formation to create and manage. So why is it not showing? AWS. Okay. Show me the cloud formation stack that created my EKS. You have to use this now. AWS console, open cloud formation service, and then find the relevant stack. Yeah, that's what I did. So why is it not showing? So okay, let me start. AWS cloud formation. I expect to see on the stack. Why is it not there? That's strange. Let me just give it a few minutes and then come back and I expect to see the stack that AWS used to create the Kubernetes. For the time being, let's continue. So where are we now? So we have created our infrastructure. All right, guys, let's move to the next thing. So now that we have our infrastructure in place, the next thing we want to do now is we have copied out all of the output, right? And we have saved them in Notepad. Once the infrastructure is ready, like it is now, you can proceed to creating and deploying applications. First, let us link our AWS CLI profile with our EKS cluster using this command. This is the command. We are going to take this command, Control-C, and we are going to replace this one with the name of our EKS cluster. All right, so let's come back here. Control V. So what is the name of our EKS cluster? Let us put it here. So let us find the output. We are looking for our EKS cluster. Look at it. Can you see? Name of our EKS cluster. So we take it, Control-C, and then we'll replace this name here with that new name. Control-V. We'll now take this command, Control-C, and what will this command do once we run it? It will connect us from here now to the Kubernetes cluster that we just created. Because if we now say, do you know any Kubernetes command? If we say kubectl get nodes, that's a Kubernetes command. kubectl get nodes. Did I not press enter? You see, it's not working because there is no connection. Even though there is Kubernetes cluster there is no connection between that and here. If we now do this command, and then we do the connection, if we now enter a Kubernetes command, it will now work. So that's the work of that command. We are now seeing the 3 servers that we saw earlier on when we went into cloud. These 3 servers are now there, ready to be used by Kubernetes. All right, we are done with that one. The next thing we want to do is create an artifact and then convert the artifact into image and then push the image into ECR. A lot of work, right? We're just going to simplify it, right? You know that to create an artifact and convert an artifact into image, you need just 2 files, the artifact and Docker file. So let us quickly create the artifact and then we'll create Docker file, right? So this is how to do it. We'll create the artifact. First of all, let's do Docker file. I hope you know what Docker file is. Yeah, I'm sure you know what Docker file is. Am I too fast for you?
No, we're following.
Yeah,
Oh, okay. All right. But you remember Dockerfile, right?
Yes.
All right. So in order to convert remember we talked about artifact earlier on. In order to convert our artifacts to image, we need a Dockerfile to work on the artifact and to convert it to image. All right, so the Dockerfile will be created here. So let's just quickly do it. We'll take this code, Ctrl+C, and then we'll create a Dockerfile with that code. But we are done with the infrastructure. So let us leave that place. cd ls -l. So the next we want to do now is DevOps basis that can create the image. So let's cd into DevOps basis ls -l. Oh, there's nothing in here. Okay, that's fine. You can just create it here, or is that the best place? Let's see what's inside this place is supposed to be the place that will hold our codes, but we are not deploying Java codes. So we have our own codes that we want to deploy. So we don't necessarily. So let's do let's do cd deployment. ls -l. No, let's do cd dot. ls -l. Where do we stay to do this? Let's go into DevOps basis. Let's stay here. Let's stay here and do it. All right, so we're going to do vi .r file, and then we'll put that file here. Then we'll save. All right, so we created Dockerfile. So we need the artifact. For this one, instead of going through the long one-to-one of doing Java and all of that, which you already know, we're just going to create a simple artifact. Let's call it vi index file, index.html, index.html. What's going to be the content? We're just going to ask ChatGPT give us the simple home page code. And ChatGPT will give us, and we'll create our index.html. Let's copy the code. Ctrl+C, Ctrl+C, and then we'll paste. This is the case where you were saying that if we copy code directly from Word, it will not work. So in this case, we'll copy it, and then we'll give it to ChatGPT and say, please, help us indent it. So let's go to ChatGPT and say, help us indent this code. We're not even going to ask the question. We're just going to paste the code. That's all. It will give us the correct version. So you say the code is already clean. There is nothing to change. So it may not give us the new version. So we just use it like. But if it wasn't, okay, let's introduce some error deliberately. If, for example, we now, okay, let's focus on the project so that we don't distract ourselves. All right, so we'll come back here and we'll put that code here. You see all of the indentation of the correctly comes out, right? Then we'll save. All right, guys, so if we do ls -l now, we have the two files that we need to create an image. This is the original artifact, and this is the Docker file that will convert this artifact into image. All right, so these are the two files. So what's the command now to convert that into image? The command is right here. The command is build, Docker build, and tag this new image that you are building. Call the image this name, and then call it version. Call this image this name, and then save the image in the current directory. All right, so if I come back now and say Docker images, Docker images. Oh, my Docker is not even running. I don't have any Docker here. So to make my Docker run, I'm going to run my Docker. Right, so if I say Docker images one more time, cannot connect my Docker desktop. Okay, give me 1 second. So we jump something. So let's go back now. Let's do, I think our desktop is running now. Look at it. Yeah, it's running now. So let's try Docker images again. Docker images. Yes, it's working now. Okay. So now that my Docker is working here, let us delete all these images that we had before so that don't matter because we had the image before. Look at it. We had this since 21 months ago, 4 weeks ago. So let's delete all of these images. So the single command to delete all of the images that I have is this command. It will normally ask me yes or no, but I've already provided the answer yes beforehand. Prune all, Ctrl+C, and then I say clear all images, Ctrl+V. All right. If I say Docker images again, there are no images. No images now. Okay, so now that we have no images, the next thing we want to do now is let us log into our ECR. You know, we created an ECR. Let us log into the ECR. To log into our ECR, we are going to use this command. All right. Then the ECR that we want to log into, we are going to put it here, the URL to the ECR. All right. So we take this command, Ctrl+C, and then we'll come.
Can you log
Sorry?
into ECR?
Yeah, we want to log into that ECR that we created in the AWS. You know, it's just like our Docker Hub.
Mm-hmm.
Yes. We use Docker Hub when you have Docker Hub username and password, and then we'll log into it. So in this case, we already have our Docker Hub ECR. We want to be able to log in with a username and password. So to do that, what is the ECR? Let's check. ECR repo URL. Let's look for it. ECR repo URL. Look at it. ECR repo URL. Look at it. We are going to take this URL, Ctrl+C, then we are going to put it in here, Ctrl+V. All right, so if we now take the whole command, Ctrl+C, and then we'll come here, we'll do Ctrl+V. That works. We are successfully logged in to the ECR that we created. So now we are now able to connect to that ECR, and any image we build here, we will now be able to put it inside our ECR. All right, we are making progress. So that was that. We just completed that. All right, so let's go into CD class app, but we don't have that on my system, let's see, do I have that directory? So that is not applicable here. If I come here, CD, in fact, don't worry about it. I'm already working with this directory, so I'll just stay here. So, or let's see, CD ls minus -. No, I don't have that directory that was mentioned there. Maybe I should create it or continue to work where I'm working. For consistency, let me create it. Let me create this directory and then work with it instead of one I was working. So Ctrl+C, because let's create it. Just before I was saying, where do we stay to do this work? Where do we stay? And then I just click here to stay, but this is not the best place to stay. So let us create a room where we will now stay to really do this. So make directory that. All right, so we have created the row now. So if we do ls minus l, we now have that row. Go. In fact, we don't need this one because we are not working with code. So we can delete that if we want. We feel that it will be distraction, we can delete. After we have not done anything. So let's go into this directory now. cd go ls minus l. I'm working in a blank room now where there is no. So now that we're in this room, what do we do now? Oh, okay, that's what we should have created these two. Oh, okay, but we already created these two. Who can tell me? How can we move what we already created earlier onto this place? Yes, we can. Instead of repeating everything. So let's go cd print working directory. So let's do cd dot cd what the ls minus. Look at the two files that we had before. All right. So let's move everything that we have here, move star into this place. Does that work? If we now say cd dot cd go ls minus l. Yes, the two files are there. All right. So finally, let us build the image. All right. Did you understand so far? We can go back and revise anything. All right. If there's no question. To build the image, the command is docker build. The name of the image just happens to be long because of the resources that we already have in place. Because of the name of the name of the image has to carry the name of the ECR, right? So this is the name of the ECR. So that's why it's not. We'll take this whole thing, Control C, and we'll say build an image out of these two files. We'll come here, and we'll say build an image from the two files above.
Sorry, can you, from this side, this ECR side, can you maybe just do some tweaking on your notes and resend it?
I don't understand. Which part?
From that ECR side, where you have to log out, move this, all this thing. Can you make sure that so that when we are going through it again, it will be more easier?
No, the note, I'm following the note directly. I wasn't following the note. That was why I was looking for. So now I'm following the note. The only thing I did not add to this note is make directory.
Yeah.
Control C. Control V. All right, so make directory that, then change directory to that. So I'm following the node directory. So we did this. The issue we had was I was not following the node. I was doing, which I would have arrived at the same answer, but at least this is more logical. You can just copy that. Okay, so now that we have created the image, do you know any command to prove that you actually created the image and the image is here now? It will be docker images. So it tells us that yes, we have created the image. Look at the image. We created it only 1 minute ago. So the image was actually created. This is the name of the image, and this is the tag of the image. But this image right now is resident only on our local Docker, on our laptop. Now let us push it to the company's repository, image repository, container registry. To do that, we are going to say Docker push. All right, so we'll come here, and we'll say Docker push, and then the name of the image, Ctrl+C, and then Ctrl+V. All right, look at it, it's pushing the image from our laptop now, our local system, to the ECR that we created in cloud, and now it has been pushed. So now we have our image, this diagram that we have been drawing, this is what we are. We have our image here now. We are here. All right, so the final stage now is to take the image from here and then put it in our Kubernetes cluster so that the image is now available for the world. And like we called it earlier on, it's called deployment. We deploy. So let us take the image from our ECR and put it in our, deploy it to our Kubernetes cluster. And that is the part that we call application is now available as an image in our ECR. Or can run some Kubernetes command to prove that. Right, so the final thing we want to do is deploy the image from our ECR to as application into our Kubernetes cluster. And that is simple to do. Okay, so to do that, we are going to create a deployment.yaml, and then we'll create a service.yaml, create them together, and then we'll say kubectl apply deployment, and then that will deploy the image from our ECR into our Kubernetes cluster. All right, guys, let's do it. So we're just going to copy this manifest, Kubernetes manifest. It already has everything you learned on that Kubernetes. And then for this one, we may want to go to a different directory. We can, it will work irrespective of how we do, whether I do it here or not. But it's just for proper organization, working according to security best practice. So we need to do the right thing at the right place so that everything is tidy. So we'll get out from this directory. Let's minus L. And then we move into the directory where we should be deploying from. Look at it. Right, so see the deployment, ls minus L. We find that there's already a deployment file there. No, we don't want to use this one. We want to create our own. So what do? We delete it, right? Remove deployment.yaml. ls minus L shows that there's no more file there. All right, so let us create our own deployment.yaml. So how do we create a file? vi deployment .yaml. All right, then we'll put there what we paste. We'll paste there. Or we'll copy. And then we'll save. And that's it. It's done. So how do we implement that deployment? We say
Apply.
yes.
Apply.
kubectl apply minus F deployment. All right. We come here. I will say apply. And that application, oh, yes, error. What did we not do right? Let's find out what the error is. Let's start troubleshooting. So ls minus L deployment.yaml. Okay. So kubectl apply minus F deployment.yaml. Validating deployment.yaml. Error validating data. Invalid object to validate. If you choose to ignore, invalid object. Let's look at our. Let's look at what do you mean invalid object? Deployment. Spelling is correct. Okay. So let's look at our manifest. What's the name of our object? I guess. Yeah. Let's change the name. Let's change this one. This is 801. Let's check the name. Are we referring to a different object? So this one will be, what's the name of our object? Docker images. This is the name of our object. And the same thing now. Control C, then 2.0. So let's compare. Control V. Go up. The same thing. I don't know where the error is coming from, but let's keep troubleshooting.
Maybe
The second one has the version 2.0.
Yes, it should be part of it. So
maybe you should copy it and create inside VS Code, create a file and paste it and see whether you see the error.
it's not that kind of error. So port 80, load balancer. Well, let's do as I said. Let's see if that GPT can identify something. Okay, from here. Define the for you. Here's the breakdown. Contain. It's exposed on port 8. Was there any change? The service does this. Port 80 forwards. And you put both manifest together in one path as deployment. Deployment. Okay, so let's run this and see. So if we come there and then we'll come back to our manifest, then we say vi ls minus l vi deployment.yaml. Then we delete all of this. All right, we'll just keep troubleshooting. I mean, it's normal. It's just that this material, as a trainer, we've done this many times. That's why everything is smooth. Normally, you don't just run things and they just run. All right, so there's always troubleshooting. So that is changed. We do uctl apply minus L YAML zone. Oh, there was an error. So this one is working now. So you see what I mean? So you directed us to go and use ChatGPT and we got the writing from ChatGPT. So this one worked. All right, so let's save the. Well, thank you for that insight. So let's save the new code now for future class so that we'll come here and we'll say Control V. Right, so this is the new. Right, so I'm just going to push. If we take our time to really study, we'll see where the mistake was from. But for me, as long as we have a working one, so there's really no need to spend so much time trying to, especially for not coders. So let me just completely save this. Okay, so that is saved. Let's see if I can bring that to one page.
And you can resend only this file when you're done, only this file.
I would always update. Don't worry about it.
After the class.
I would always update the content of that, of the Google Drive. Okay. Okay. Control-S. All right, so we have deployed to our Kubernetes cluster. Is it live? Let's browse to see if our application is live. Right? So to do that, how do we browse our Kubernetes cluster? Do we have any IP address of our Kubernetes cluster? kubectl. Oh, we are using a load balancer. Right? So we just say kubectl get Debbie. And then to give us the URL of our load balancer. Right? We don't need any IP address, we just copy this URL. Proceed. And provided we give enough time for the load balancer to form and all of that in cloud, in AWS, then we should be able to browse our application. Because it's not in production, it's not in operation. Yeah, so that's it. Because this is the application that we do. All right, so that's it, guys. We've been able to complete setup of end-to-end infrastructure, and then we're able to deploy a sample application in there. Any questions?
So I'm reading the project, and it says, where is it again? I think I've scrolled down. That my team had a project to migrate an on-prem application to AWS cloud for a client.
Okay.
So is that the image that we
So
create?
yes, so your team has this project to migrate a whole application all the way from non-cloud environment to cloud environment, and they choose to do that on AWS. So it's a team job.
Okay.
So your own task there was to study and understand the current environment under which your client, Bank of America, operates. What kind of database, what kind of network, what are the resources that are a lot of study that can take up to 3 months. So you are part of the team that is studying to understand the current environment so that you know that when you are moving this application to cloud, you have to create a similar environment in cloud for the application to inhabit, and then follow best practice to replicate this same scenario that you are seeing and studying now. You want to replicate that scenario in cloud. So the action you took, having studied and understood that situation, was to build, test, and deploy the Terraform manifests. All of the Terraform manifests that we saw earlier on, we were part of the team that built them, tested them on your individual machines across. Some people were working from China, some from Africa. And then once you were sure that the manifests were working, you now push them to the repo, where it is now centrally available to the entire team. The whole idea is that you want to automate the provisioning of all of the infrastructure needed for this project, right? And the result after this whole task as part of the project were completed is that your infra automation eliminated the manual. Okay, so in this part of the project, we are focusing on the provisioning of the infrastructure. You know, the project was big, taking care of provisioning of infrastructure, provisioning of converting of image from artifact, and then deploying the image. Yes, but this project is particularly saying that the part that you want to emphasize and claim is the part where you used Terraform to provision your infrastructure. In this case, your infrastructure is Kubernetes, right? So the technical project Now, give me the details. Share as much detail. If I give you 1 hour or 2 hours or even 3 hours, you'll not be able to give me all of the details. So share as much details as you can within the next 10 minutes of your involvement in this project. So the details now is that you were part of the team that assembled all of this manifest, and then you were able to run this manifest to produce the result that we saw here when we came into cloud. We saw that an ECR was created. We saw that S3 bucket was created. We saw that EC tools were created. Kubernetes clusters were created. What else were created? And so on and so forth. We want to be able to explain the process that took you from this to being able to successfully deploy the application, so that at the end, we're able to, as customers, we're able to see the application live like we are seeing it.
Okay, so in a real life interview setting, will like the task, it says study and understand the current environment. Is that a module that will be provided, or?
Is there a module? No, it's you that would, you are trying to explain your involvement in this project. So in real life, the customer has asked you to come and migrate their application to cloud. So it's not likely that you sit in your office and ask over the phone, how do you operate? What does the application do? How many RAM does the application currently use? How many customers do you have? So it's likely that you want to go to their on-prem application and study all of these things on your own, by yourself, as a team. So there'll be a team of developers made up. There will be a team made up of developers, you as the DevOps engineer, network people, your business analyst. Everybody, maybe like 5 of you, will report to that office every day for the next 3 weeks to do this, to understand it.
Me as a DevOps engineer, can I pick 3 manifest file and say, okay, this is the part I was involved in?
Yes,
Why
you
is
can.
he explaining the overview of what was actually done, including
Yes.
infrastructure?
That's a perfect way to look at it. That's a perfect way. Rather than claiming that you created all of the 15 files by yourself, you can just focus on the main 3, or even the main one. Or saying that you are part of the team that built the whole thing, but your own focus was that equal. Yes. So does that, the question you asked earlier on, the lady there, did we manage
I'm just trying to understand exactly the scenario in this question, if it's an actual interview question. That's the part where it says the task for me to study and understand the current environment. That's the part I don't understand. Are they going to give us like an environment to study? Like an existing, application that we can look at?
That's what we just explained now. I said yes. And then I gave, yes. So it's not they giving you, is this Bank of America says, or some website, some online marketing person says, my business has grown beyond me just running this in my office. I want to move this application to cloud. So that was where I said, when you get that kind of call, your office gets that kind of call, and they charge $2 million to do that, your office is not going to sit all of their 35 staff in their office and be talking to this client over the phone. They will have to set up a 5-man team to go to this man's site and study and understand the current environment, software, hardware, data center environment where this application is running, and then understand that environment enough to be able to replicate that environment in cloud.
No, I understand the real world application of that.
Okay.
Yes, I'm just saying right now, if I'm interviewing, obviously I'm not going to be interviewing with a team.
Okay.
So I'm sitting by
for the interview purpose, you are going to cite that real world environment that you just claimed you understand. That's exactly what you are doing.
Okay.
Yeah.
I see. That
So that's
was
what
my
they
question actually.
Oh, okay. So that's what they are always interested. In fact, that's the whole essence of this training. You want to be able to present everything you know from the perspective of the real world as much as possible. No one is ever interested in theory. Even all of the change directory, make directory that you know, you have to be able to relate it to real life environment where you have used it. So yes, this interview is trying to find out where you have done this in real life environment, even if it means quoting a company like American Airlines or quoting one company. The more you relate it to real life situation, the more impressed they are.
Okay.
Yes. We are going to say, yes, there was this case 6 months ago, or there's this case that this project that I am currently on, where, so yeah, you must relate it to real life environment. Or there was a project that I handled 2 years ago where we did this, and my specific role as part of the 5-man team was this, and so on and so forth. Yes. The more you can, in fact, that's the difference between somebody who has done theory only and somebody who has done the practice. They want you to be able to mention. In fact, sometimes they will even ask you, what company was this? It's up to you to use your discretion to say, for confidentiality, I'm not allowed to mention it. Or if you are bold, you can mention the name of the company.
I can say we signed an NDA. But
Yeah, to mention the company may not really, it's simple. It's when they begin to ask for detailed information about what you did. That's when you may mention that I'm not allowed to do this. But for company, or at least the industry, if you say for confidentiality, I'll just mention it's an airline company operating with headquartered in Dallas. If you say something like that, then they're already thinking, oh, it must be American Airlines, something like that.
so this template is applicable to both medium and large scale company. This template.
Yes, especially for large scale, because the example that followed here is a large scale example. Yeah, but it's also applicable to medium.
Sorry, again, how are you able to display that endpoint? I mean, that on the browser. Can you do that again?
So I went to because the deployment is saying there are 3 kinds of services I can deploy. For this particular deployment, is saying create. It says create a load balancer. So because we are using load balancer instead of what are the options? What's the other option for you? Instead of node port kind of service, we are using load balancer. Then it will display a link on that load balancer for us. But if we're using node port instead of load balancer, it will display an IP address.
So we'll just type the IP address slash the port number.
That is port number, yes. Hold on the port number. But in this case, since we are using load balancer, it gave us a link. And if we go to cloud, if you did AWS, we are going to see that a load balancer was actually created. A whole lot is going on in the background that is doing for us in AWS. So if we go here now, we'll go to EC2. Then you are going to see that load balancer that you spent 2 weeks to learn in AWS was just created for you here without even you knowing that. Look at the load balance. Look at it. It was created for you. And this is the URL that was given to you there that you just use casual. Look at it.
The output.
Yes.
The record.
Yeah, the record. So the beauty is that you don't need to come here to pick anything because of everything is just available, right? Or in the background, that's what's actually going on. Over 65 different resources have been created for you right here in cloud, all the way from what we are doing here. So this is why I was able to pick that. So I just copied this. As long as it ends with .com, it means it's a valid URL. And then I
Okay.
Yeah, so much work in one day because the assumption is you already know the pieces. So we just use this big project to put all of the pieces together. All right, so now that we are done, let us destroy everything that we have created. Otherwise, our bill will just be coming in hundreds of dollars every month. Go back to the node, ready to destroy. We can delete our image from the ECR and then delete our ECR remotely.
So if you destroy, it's not gonna delete the image.
It will delete everything, but this is the procedure to do it. So delete the image and then delete the ECR.
Okay.
Yes. All right, so you come here and we'll say Control C. Then we'll come there and we'll say Control V. All right, so that should have deleted that. We'll now say, do we have any ECR over there in cloud? If you come here to ask, tell you no. All right, so 1 down, 3 to go. So you now say destroy all of our infrastructure. It will be TerraGrunt destroy auto. All right, Control C. And then we may not wait for that to happen, but that is it. Because we created with TerraGrunt, we must destroy with TerraGrunt. What's the problem? Okay, we're in the wrong directory. This is not where our Terraform files are. ls-l. This is not the place. So cd out of here, ls-l, cd into infrastructure, ls-l. Okay, this is the place. All of our TerraGrunt files. Okay, cd TerraGrunt. Okay. That will take a couple of minutes, and then once that is done, I also use this command to empty my bucket and destroy my bucket.
So all these procedures these are the procedures to delete everything.
Yes, it will delete everything.
Yeah. But if you still use Terragon delete Terragon delete auto approve, it will still delete everything.
Yeah, that's what we're doing now. That's the one that is working. It's the look at it.
Yeah.
TerraGrunt delete. It's deleting everything. But remember that you created where there are resources that are outside that you did not use TerraGrunt to create, that you created individually. So TerraGrunt may not be able to delete them. You know, that's how we're now deleting them outside TerraGrunt. So put differently, TerraGrunt may not be able to delete everything. So what's my name? So from experience, TerraGrunt did not delete my ECR because the ECR had content and it will not be able to delete it when it has content. So I had to first of all remove the content and then delete my ECR. So that way, I'm making TerraGrunt work light now. So after it has deleted everything, if I check and I still see anything remaining, especially because that thing has content, for example, my S3 bucket, and it says I'm not able to delete it because it has a file inside, then I'll have manually look for another way to delete it, basically, whether it's manual or that one.
Yeah, because this is money.
Yes, if you leave them, you just
you just wake up, you just see $500 or
may not be up to, but at least every dollar counts. So with this one, mind is at rest. You can sleep with your eyes. The brain will be right. Yes, so we don't have to wait for the whole deletion to complete, but that's just the. All right, so as for monitoring, we don't need any other. Already know how to. All right, guys. That's it. That's it. That's it. What are we doing here?
Don't forget to share the.
Yeah, I'll upgrade the notes in the drive.
So I have a question not really relating to what we just did.
Okay.
So I was reading somewhere that DevOps is actually not considered like an entry level type of role. So do you have any tips on where to apply and how to get about even getting this interview in the first place? Because a lot of places ask for experience.
Yeah, you are going to claim, you are not going to, with DevOps, with everything you have learned now, in the last 6 months, you are no longer entry role.
Yeah.
So, in fact, there is no IT role that you just say I'm entry unless you want to do intern, and then you show that you are fresh from university. So,
Yeah.
with all of this, if you're able to practice all of this, you should be able to claim at least 3 years of experience. But comfortably, we'll prefer that you claim 4. If you are coming in with 4 years of experience based on the practice or your practice of Linux, your practice of what we taught you in AWS, your practice of infrastructure as code, your practice of everything in this note, 36-page DevOps1, another 60-page DevOps2, all of the repositories, you know everything, then it's more than enough for you to claim 4 years of experience, showing in your experience these projects that we have executed together in the past and which you should execute on your own. So in that case, from that perspective, you are not entry level, and then you can try places like LinkedIn, Indeed, what are the other two? So in the order of popularity, Monster, yeah, and then so LinkedIn, Indeed, Monster. There's one more. So these are the two, 4 popular places. Then, as your colleagues begin to get job and they are getting interview and the news is spreading, then that would also help direct your.
What about online, like an online job where you have to, like, maybe you can be here and work, maybe you can get a job in Europe and you have to do it online. Is there any
Remote jobs, yeah.
remote job? Yes, exactly.
There are lots of remote jobs for DevOps, especially.
Yeah.
So that's I know you sent us like a resume sample. So
Yeah.
for experience purposes, are we going to put the iTurn?
How many months did you do with us? Only people who did 6 months will know enough to be able to, your trainer knows enough to be able to do this. Say yes.
Yeah,
Yes.
and again, can we use you as a reference too?
Only if you did 6 months with us. Yes, only if you did 6 months with us. That way you are my intern, then I can know you enough to defend
We've done more
all
than
your
6 months.
or your trainer. I mean, the intern generally, even if it's not me as it is.
Again,
yeah.
I plan on writing AWS this solution architect certification. So what do you think about it? You think it will boost?
Definitely. There's no thinking. AWS Solutions Architect is a heavyweight certification. Yes. In fact, that's only one that we recommend amongst everything that you have done. I mean, even if you don't do any other one, you should do that. And then if you intend to do more than one, at least have that one first and you can do anything else on top of it. Yes, it definitely will boost.
So once I do that one, I pass it, then I'll just add my training with akin and my bachelor degree.
Not your training with iTurn, the knowledge that you gained from training with iTurn.
Yeah, I know.
Yeah. Okay.
I'm talking about the when on my resume if I'm doing the education side of it, you know, if I'm highlighting the education side of it.
iTurn should not appear under education. iTurn is not academics. It should be
Like
the
a
knowledge gained there that you are using somewhere.
Yes. Sorry, that's what I'm trying to say. Sorry, yes.
Yes, so the original question was, yes, even if it takes you another 4 months to practice all of these things, to be able to understand them, to say, okay, this is what he was trying to explain in class. It's worth it. Otherwise, you may not be able to defend what you have in your resume. So no, you're not coming. I mean, we've had people in fact, I've had to caution people to take only 3 years experience and 2 years experience, and they tell me, Mr. Akin, you don't know what interviews I'm already attending, which is for me that I'm claiming 7 years. I say, how are you going to defend? Say, don't worry, just leave that to me. And then they come back to say, well, not all of them. Some will come back to say, I got that job. Oh. Yeah, it was tough. It's always tough. It was always tough. I got it. Then that's how we remain in business, because they will say, somebody that I had, he did not even complete training, to be honest. He got job like 2-3 months into training. And then he was contacting me recently to say, Mr. Aki, you don't know me. He said, but he didn't complete training. I said, because the job he got so busy he could not complete training, just focused on that. So right now he has 3 jobs. And because of that, everybody's on his neck. How they come and teach me? How did you learn? So he directed 2 people to join the Nigerian training, and then 1 person to join this training. 3 people altogether. So what point am I making? That yes, people just attend classes, and because they're able to defend what they learn in classes, they are, even without prior experience, because you will not be doing this, you have prior experience, they are able to get jobs. So you have to be able to defend. Practice these things enough to be able to, if you're able to, I know that under interview conditions, you'll be nervous and all of that. Even if you're able to remember only 70% of what we have covered so far, you're able to express your understanding of this concept. You are good.
Yes. So this issue is very broad. You cannot understand everything.
Yeah.
Just once I can get a hold of the flow, and then get a hold of the infrastructure side and the pipeline side of it.
Mm-hmm. That's good enough.
Yeah.
That's more than good enough. You understand the concept, you understand the workflow, you're able to explain that, and then you master the infrastructure, the CI/CD. Those 2, yeah, that's good enough. Mm-hmm. All right, so let me not keep you waiting for this. There's nothing more to do other than just keep it.
Please, okay. In case if we just maybe you have a urgent question, it's not as if we'll be calling you, but we just maybe we are kind of like stuck somewhere or confused.
Yeah, the group
what's
is
the best
still
way
active.
to get
The group,
across to you? The group, okay.
Yeah, just post your. Raymond is still there. I'm still there. So whoever is able to answer first, they will answer. You post the screenshot of any issue and be able to support. All right, guys. So that's it.
Okay.
All
Thank you
right.
very much.
I'm gonna have to let you go. What about the other guys? Tell them, share them. Share the experience here with them. If they need their own classes, now you know enough to be able to train them on what they have. There are 2 other guys, right? Train them on what they have missed.
Yes.
All right.
We keep saying we're going to get together and do something, but
Yes, we have to do it. We have to, because that's the best way to, like, brainstorm and collaborate.
Yeah, it's a good one.
Because one person might not be that easy like that, but
it's not. Everybody's schedules is all over the place. Everybody is working for a living, so.
Yeah.
Yes, I'm telling you, man, it's not easy, man. Not easy. You gotta go make this money and still come and do this one. Like,
Yeah, you guys have tried. You've done the financial investment. That's good. And you need to make time to put in the time that requires. And then some of these things may not make sense instantly. Or when you're looking at them like in 3 weeks, 1 month, 2 months time. Okay. As somebody returned to me recently to say, it's now that the training he completed in March or so. It's now that the training is making sense. So now he's really understanding. Can I join when are you having the next class so I can join as a refresher and hear these things over? I said, okay, we are starting a new class next month. Come and join as observer and just watch. So it happens like that. Sometimes they may not make sense immediately. And then 2 months later, so take your time. When you don't force it. Even for me, sometimes I'm trying to do something, doesn't. Just take your time off it, take a walk or do something. 3 hours later,
So
Just find let me go and try that and just works. Or
yes,
it may not be 3 hours, it could be a whole week, 2 weeks. Then just
thank God for ChatGPT too.
yeah, that one is also different. All right, guys. We'll see you again on the WhatsApp chat if you have any issue. Otherwise, I wish you all the best as we explore these materials to begin to move forward.
All right.
Thank you very much.
Thank you very much.
Thank you.
Good night.
Good
Have a
night.
good night.
Good night.
Bye.
Yeah.